All right. Okay, so if you look into this right now, um, so in here we have the username present and the host ID present. Atlanta.com is the host ID there. So from the next thing, we can easily recognize what fields are present in an easier way. So what things we have here? We have username, then we have password also, and there is the host ID. And what we have after semicolon, whatever we have is called as URI parameters. Transport is TCP, meaning is SIP is working on TCP transport on the host. It is not working on UDP transport or not working on SCTP transport, because SIP is one unique protocol which can use any of the transports that are available in the market. So here it is choosing that the transport mechanism the server is working on is TCP. Then we have SIPs, which is also a URI, but SIPs represents secured. So there is security activity enabled like ciphering and deciphering, etc. So only username is present. At the rate of Atlanta.com is the host, or we call it as domain. And directly we have started the question mark. So semicolon is not there. Directly we have the question mark. If semicolon is not there, we know that the parameters are not present. What is present? Whatever is there after question mark, we know that those are headers. So some of the header field information itself is copy pasted, like the subject header field is copy pasted here. Okay, so that is that. So whatever is that subject, we will understand that in the coming up subtopic. Then we have SIP. Um, the user ID we have here is like a phone number, and this 1234 is the password. At host is gateway.com. The gateway.com might be linked to the your PSTN gateway, and this is the phone number to where you are making a VoIP call from a VoIP device or a SIP device. You are making a call to even landline phones. So this gateway typically will be connected to ISDN. From that ISDN, the call will be routed to the your PSTN or PLMN, depending on whether this number is leading to PSTN or PLMN. And the user is equal to phone is one of the URI parameters included here, represents that this particular phone number is this particular user ID is a phone number. It is not a SIP user ID, it is a phone number. So that is what it says. SIPs 1212 at the rate of gateway.com. Here 1212 here is user ID because it cannot be password. Anything that is present after SIP or SIPs should be a username. 1212 a username at the rate of gateway.com. SIP allies at the rate of 192.0.2.4. So allies here is the username, and 192.0.2.4 is the host or the domain name that we have there. And SIP Atlanta.com. At the rate symbol is not there. If at the rate is not there, means directly we are linking to host directly. So there is there is no user ID and the password part not present. Directly we are having host ID here, Atlanta.com. And there is a semicolon that represents that we have URI parameters. URI parameter we have is method is equal to register. And there is a question mark. That means some of the header fields are also copy pasted into here, this particular place. Some header fields also copy pasted. SIP colon allies semicolon. SIP colon allies. This allies is basically is your username, because we have at the rate symbol present. This day is equal to Tuesday. This whole thing is the password. So that whole day is equal to Tuesday is the password at the rate, and Atlanta.com is your host name or your domain name, where this allies user is present, whose password is this day is equal to Tuesday. So Depending on the at the rate present or not present, we can recognize whether the user ID is there or not there.
Sir, I have a doubt for the last one, sir. Alias colon is there, right? Sir? Colon,
It should be
so sir, it should
semicolon.
be
It should be
user
semicolon.
parameters, right, sir?
No, it should be semicolon. Actually, that was a mistake.
Mm-hmm.
That was a typo. But it should be a semicolon, not a colon. Okay. Um, so SIP URIs always will be representing the user IDs. User IDs are the SIP service IDs, depending on what kind of service that you are providing. It is that the SIP user IDs. Okay, great. Next, what we have? SIP URIs comparison. Which SIP URIs are equal? Which SIP URIs are not equal? Um, for example, we can write a SIP user ID like this. These two user IDs, SIP URIs are equal. The uniform resource indicators are equal. How they are equal? We see here percentage 61 is a ASCII code represents a character A, character small a, lies. The total thing will become allies. At the rate of Atlanta.com, Atlanta.com. So in some of the header fields, capital letters and small letters will be considered the same. At least domain names will be capitals and smalls will lead to the same IP address. So irrespective of whether you type google.com in capital letters or small letters, it will connect to google.com IP address only. So that is that. Transport is equal to TCP. Here, transport is equal to TCP. Here we have a smaller case here and uppercase here. Uppercase starts and lowercase here. Doesn't matter if either you use it this way or this way. Both are actually representing the same meaning. Similarly, SIP Carol, the username is Carol at chicago.com is the domain name, and something called as a new parameter is equal to 5. Security is equal to on. Whenever we are having different parameters, even though those parameters are not present in the first one, parameters differ in the second one and the third one, still we'll consider the URIs as the same URIs. That means we are ignoring the some parameters like new parameter, security parameter. All these things we are ignoring. We are just ignoring the parameter differentiations, and we are considering all the three URIs as the same. Similarly, these things are also equal. Oxy.com, at the rate is not there. We can say that it is just directly the domain name oxy.com. Transport is TCP. Method is register. Two is SIP Bob, SIP colon Bob. At the rate of 40 is percentage 40 is at the rate oxy.com. Or oxy.com, you are just reversing the things. So instead of placing the transport is equal to TCP first, you have placed method is equal to register, and then you have kept transport is equal to TCP. Then you have placed question mark and here. That means parameters can change their order. Even if the parameters are changing their order, still we consider them as equal. Um, Subject here, priority here, and subject here. So even you can change the header fields that you are attaching to your URI. Still, they are going to be considered as equal. Okay, so which are not equal? If you are considering allies at atlanta.com and allies at atlanta.com, here allies is a capital case and here it is small case, lower case, and both are not maybe equal. Even though the transport part is equal, usernames are not equal. So usernames, there can be one username with some letters small case, some letters capital case. Both users will be considered different. These two things with the subject information present, header components are present, different header components which are considered as not equal. Or if transport is not mentioned here and transport is mentioned here, this might resolve to TCP transport. That means this is working on TCP, this is working on UDP. Both these URIs will be considered different. If you take biloxy.com, here you did not mention the port number, you have mentioned the port number. So this port number may be a different port number. We might be considering that not equal. And here also same port number is not there. Port number is present here. Transport is not mentioned. Transport is mentioned here. So this could be using a different port number and a different transport. Like transport could be UDP port number can be different. So can resolve to different ports and transports. So we have to consider them as not equal. And here we have a domain name in FQDN. Here we have address. This domain name may be resolved to a different IP address. So that's why both the things will be considered as different. They are not equal. So which SIP URIs are equal, which SIP URIs are not equal? There are a lot of conditions and rules that they have mentioned in 3261 specification. Here are some examples for that. So which SIP URIs would be equal, which SIP URIs won't be equal. Okay. So with that part, we are done with um, something called as request line part, which is containing the method request URI and SIP version. At the end of it, we'll have the CRLF, carriage return line feed. All right. What do we have next? We are going to discuss status line. Status is the reply that comes for the SIP messages. In the status line, we are going to have SIP version first, space, status code, what happened to your request that you have generated, um, and space, reason phrase, and CRLF, carriage return line feed, status code. So it is a 3-digit code, which will be either 100 series, 200 series, 300, 400, 500, or 600 series. Every series in 100 series are called as provisional responses. That means the guy who is responding back is telling you that I have received your request, man. I'm continuing to process your request message, but I'm just sending this message to you just to notify that I have received your request. But this is not the actual response. You have to wait for the actual response. So these 1xx responses are called as provisional responses. For the time being, the other guy is sending you a provisional response. Remaining all the responses are called as final responses, either 200, 300, 400, 500, or 600. They are called as final responses. Only 100 series are called as provisional responses. They're just temporary responses. 200 is reporting success. So any 200 cores are mostly likely represent a success. That means whatever the transaction that you have initiated is getting reported as success if you are getting a successful response. 300 is 300, 400, 500, and 600. Almost all these four things are representing failures. 300 represents redirection, meaning is the server is coming back and giving you the task. Hey, I could not process your request completely. I am giving you some suggestions. You have to do this now. So I'm redirecting it to somebody else. Go to that, go to that fellow. I'm, I'm not doing it myself. Client error. So, hey man, whatever the message that you have sent, the request message that you have sent is containing a bad syntax or I cannot fulfill it this particular time because of something wrong. So, such kind of errors will be called as 400 series, 4xx. 500, the server failed to fulfill the apparently valid request. That means from the client side, the message arrived perfectly. There is no problem with the message. Everything is looking good. But server itself is having issue. It's not the client related issue. So server is reporting that my bad. I'm having the issue. 600 global failure. The request cannot be fulfilled by any server is called as a global failure. It failed everywhere. You wanted to initiate a service. You are okay with any server which is providing you the service, but I could not find out a single server that can help you out with this particular service request. Called as a global failure. So 600 series. So which number you get will be dependent on what server would like to send back to you. That is the status code. What is SIP version? SIP version is 2.0. Reason phrase is a information that is explained to the human beings. Basically, because normal humans won't understand this status code. For them, we need to have a reason. What happened? We need to have a reason. That is the reason phrase. It is English. In English language, it will be present. So the receiving component will never examine the reason phrase It is only for human beings understanding. This just for a human user, this reason phrase. CRLF stands for carriage return line feed. The value is the same. So we know what is this carriage return line feed. Carriage return value is 13, line feed is 10. We have this. Great.
Sir, actually, I have a doubt. Sir, related to 400 series, sir, sometimes we're getting like error 4, not 4.
Hmm.
So is that belong to the same 400 series?
Yes.
Okay, okay.
404, are you talking about HTML?
Okay, sir, but mhm.
Okay, actually, these
Yes,
codes
sir, go ahead.
we use, the codes that we use actually are this convention is followed in many protocols. Even HTTP also will have this codes in the same format. 100 means provisional, 200 means success, 300 is redirection to different web pages, 400 is whatever the web page that you are trying to access, that your web page name is wrong, 500 is the server problems, 600 is the global failures. So the same codes will be used in HTML also, but HTML code meanings are different and SIP code meanings are different. But not only in HTML and SIP, we use the same convention in many other protocols as well. So but we have to learn each protocol separately and what are the codes present in that protocol separately. Even though the this response code concepts are present in many protocols. But your idea of asking is okay. 404 error you see which says that the page cannot be found. So that means whatever the page that you have typed is wrong. The page name that you have typed is wrong, or it is not available anywhere on in the world, so it cannot find out that page. So literally, it means that. Okay, but the concept of 400 being a failure is the same in HTML as well as SIP. But the 404 that you refer to may be HTML, or if you are talking about your IMS calls, um, like Reliance Jio IMS calls or whatever, it if that is showing on your mobile phone screen with a 400 reason, then you might relate it to the SIP and say that this is related to a SIP error, client error. Okay. So which part we have completed so far? So if you take any SIP messages, they will contain request and responses. Um, so every SIP message contains one start line. The start line can be request line and status line. So far we have completed the request line, status line part. Then we are going to have the message headers, header fields that will be present, message headers. So what these message headers are. Um, so in the header, we can have many header fields. The header fields are also text-based information. In what format it will be present? Field name, colon field value. For example, field name is the subject, colon lunch. Meaning is we are making a SIP call for talking to somebody about lunch. Okay, so now after the subject and colon is mandatory after the name of the field. Uh, Before the field value, you will have colon and at least one space must be present. After that one space, how many number of spaces you contain, that's your choice. But mandatorily, you need to have one space. Then you need to have name of the element, the field value. But before the colon, how many number of spaces we want, it doesn't matter. After colon, one space is mandatory, but additional spaces, if you want, you can have it. After the subject, you can have a lot of spaces. Um, After the subject, of course, here there is something wrong here. After the colon, you must have one space mandatorily. Then we must have field value and the subject colon space lunch. This is also allowed. So like lot of different options we can use. There is no restriction as such. But Um, so every field in a protocol header will be like this. Now, you can have it this way also: field name, field value, star, comma field value. You can have multiple field values also. For example, there is a parameter field called as route colon. There is one field value, comma, another field value, comma, another field value. Actually, this is equal to writing a route one field value, then next writing the same route another field value here, writing the route and another field value here. Actually, this and these two things are equal. So you can have one field name, with one name you can have multiple field values, or we can repeat the field name multiple times and you can have one field value every time with these fields. So both options we can follow any option that we want in SIP. And field name, field value, star, semicolon. If there is a comma, this is containing multiple field values. But if it is a semicolon after the field value, semicolon, then you are going to have something called as parameter name and parameter value. For example, you have a field like this: contact colon. This is the field value up to semicolon. After semicolon, we have a parameter name called as expires is equal to 3600. Uh, Meaning is this contact field will be expired in this time unit. So this will be live only for this much time. Or you can either use small case or you can use uppercase. Both represents the same meaning. These are all the header fields that will be present in your SIP protocol message. Now, each header field is going to be ending with, after each field, you will have a CRLF, carriage return line field. I did not write it here, but at the end we will have CRLF after every header field. After all the header fields are completed, after the last header field is completed, you will have two CRLFs. You have one CRLF and another CRLF. You'll have two CRLFs after the complete header fields are completed. So if you take that in a SIP message, there are five header fields. So you have one CRLF here at the end of first header field, one more, one more, one more, one more at the end of the fifth field also. We'll have one additional to represent that this is the end of this is the end of header itself. So it is all textual language. There is no length fields, nothing. How do we know when the header fields are finished? Is whenever you see there are two CRLFs present one after the other, you know that that is the end of your header field. So how many such fields we can have in the header field? Many. How many? It will be dependent on what message you are sending, and for that message, how many header fields are mandatory, etc. So that is the message header part. And after the message header, which each field containing one CRLF, we will have one end CRLF. That will make the second CRLF, two CRLFs one by one. And after that, an optional message body. So what is this message body, optional message body? That message body represents, um, the content, higher layer content. So what is this higher layer content is all about? Um, In the header fields, you have two additional fields explaining what kind of a higher layer content is present, what type of content is present, what is the length of the content, what length we are talking about, what is the content we are talking about. It is related to the multimedia parameters that are embedded into your SIP protocol messages. If at all we are carrying the multimedia parameters, then we will be having this content type and content length fields present, explaining what kind of a content we have had and what is the type of the content and what is the length of the content, then followed by the actual content itself, the higher layer content explaining multimedia parameters. So that is how the SIP messages are designed. So start line, message header, CRLF, message body, which is optional, maybe there, may not be there, it is just optional there. All right. Um, so what do we have to study right now in order to understand this whole operations? We are going to go through um, some call flows. Okay. Um, in the examples that we are going to study, the SIP examples we are going to study, there are going to be these components that are in play. There is a user agent called as Alice and another user agent called as Bob, two user agents. And there is one proxy server. There is another guy who is acting as proxy and register, one more proxy server, and ALG, application layer gateway. Where do we use this application layer gateway, for what purpose we understand? And for all these components, all these elements, SIP elements, there are URIs, uniform resource indicators. So Alice guy is identified as Alice at atlanta.example.com. Alice is the username. Atlanta.example.com is the domain or the host name. Where this guy is present, what is its present IP address throughout this document we are going to study is 192.0.2.101. Bob at the rate of biloxy.example.com IP address is this. Bob can be present in multiple domains depending on his present location. He can either be registered with biloxy.example.com or chicago.example.com. So these are the two domains where Bob can be present. But when Bob is present in biloxy.example.com, his machine's IP address is going to be considered as 2.201. If this guy is present in chicago.example.com, it's going to be 2.100. So there is proxy servers SS1, SS2, and SS3. SS1, SS2, and SS3, these are the IP addresses 111, 222, and 233. And the ALG component address, wherever we use, is going to be 128 is the address, 2.128. So these are the components that are going to be in play for our procedures that we are going to study. And we are going to start with our first procedure, SIP registration procedure. We will be studying these SIP procedures one by one. And so there is a Bob guy who is doing the registration with the SIP server by using the register method. And here F1, F2, F3, F4 represents typically F1, F2, F3, F4 represents the steps in the adder. So first Bob guy has sent a register method to SIP server, and SIP server has sent 401 unauthorized. 401 is a client error as per the discussion that we have had. It is a client error and the explanation is unauthorized. Again, we are sending register in step 3 and server is sending 200. 200 represents success. It is okay. That means your registration has been accepted. You are trying to doing the registration that has been accepted. This is the fourth step. So each step is going to have some protocol messages present here, and we are going to go through and study those protocol messages. First, step 1. Um, this is the first step that we have seen in the picture, register, which is going from Bob to SIP server. This is the full SIP message that we are going to have. Um, First, we have the method name register. If you remember our structure in the request line, if you take a request line, we have the method name space request URI space SIP version CRLF. So if you go back to our here, this is the method name register space SIPs. So this is the URI ss2.biloxy.example.com. Uh, SIPs colon is there and at the rate is not there. Whenever at the rate is not there, we can understand that this is a domain server, which is being hosted at this particular FQDN. ss2.biloxy.example.com is a fully qualified domain name, which can be boiled down to a IP address as per the earlier story that we have done. ss2.biloxy.example.com, that is the URI whose IP address is 192.0.2.222. So if anybody wanted to find out the IP address, this is going to be the IP address of ss2.biloxy.example.com. So we are trying to do the registration with that component, that is the URI we are keeping, SIP URI space SIP version. SIP backslash 2.0 represents we are using SIP 2.0 protocol mechanism. Then we have the uh, once the one in any SIP message, in any SIP message, what we will be having is after the start line is completed, we are going to have the message header. What will be part of your message header? Your message header is going to contain, sorry, your message header is going to contain header fields. Each field is going to have a field name, colon field value, and at the end we are going to have the CRLF. So if I go back, all these are header fields. First header field is via colon. And what is via typically? Via is normally going to represent um, the the message is traveling through which components. So that is the meaning of this via. So in the via field we have SIP 2.0 TLS. SIP 2.0 is the version number. TLS is transport layer security. We are using the transport layer security mechanism here. And the via field is representing that client.biloxy.example.com 5061. So this is where the message is going through. Who is this client.biloxy.example.com and port number 5061? Who is that guy? If you go up, that client.biloxy.example.com, here we don't have anybody with that name, biloxy.example.com we have. So there is this Bob guy is only available there. So at that ID. So this is another name for the Bob guy itself, client.biloxy.example.com, and code is 5061. And there is a branch parameter. What is this branch parameter? We will understand. We will come to that in some time. But we will ignore that branch parameter for time being. For another 5 minutes, we'll ignore it. I'm going to introduce this branch mechanism in some times. Maximum forwards is another header field whose value is going to be set to 70 maximum forwards. That means this register method, this register message can be sent maximum 70 times from one server to another server to another server. It can be sent through 70 components. After crossing that number, this message must be dropped. Every time this maximum forward value will keep getting decremented. It is like your IP packet TTL value. So 70 will become 69. 69 will become 68, 67, like that. But if it directly goes to the server, it never need to be dropped. But if it need to be forwarded from one server to other server to other server, that time the value will keep getting decremented. Whenever the value becomes zero, the SIP message would be dropped. From will be representing the component who is initiating this register method. The component who is initiating this register method is Bob at biloxy.example.com. This guy is the one who is initiating the register method. So that is why this SIPs Bob at biloxy.example.com is present. Now, there is a parameter called as tag. Even this tag also we will be ignoring it for some time. I will introduce this after 5-6 minutes. So just hold on to the tag parameter. Now in case when we are doing the register method, the to address is also going to be same as the from address. If you are making a SIP call, typically from address and to address will be different. If I am making a SIP call to you, my address will be present in the from, to address will be your address. But when I am doing a registration, as I am not initiating any SIP service or SIP method, so both from address and to address will be pointing out to my address only, bob at biloxy.example.com, bob at biloxy.example.com. The reason for this is This guy is not initiating any SIP session. He is trying to perform a registration with a server. Server's address is ss2.biloxy.example.com. With this server, we are trying to perform a registration operation. And call ID is a concept in SIP where a unique session ID will be created. That is what is called as call ID. It is going to be unique worldwide. No SIP sessions, no two SIP sessions will have the same call ID. And the machine which is generating the SIP message, the SIP protocol message, will make sure that this call ID is unique in the world and it will never get repeated. It will make sure that it happens. And C sequence is a sequence number basically for your SIP message. It is one first sequence number one. Um, you are not retransmitted it or something like that. It is one right now, and the method name is register. Register method sent one time, first time. Contact colon SIPs bob at client.biloxy.example.com. So what is this bob at client.biloxy.example.com? So this Bob guy is telling that, hey, actually my SIP URI is bob at biloxy.example.com, but I'm reporting that my IP address contact field typically contains your IP address. Either you can quote your IP address directly, or you can quote your URI or FQDN, fully qualified domain name. So the Bob guy is not quoting his IP address in the contact field. Instead, it is telling that I'm giving you my FQDN, fully qualified domain name called as bob at the rate of client.biloxy.example.com. If you go and provide this information to any DNS server in the world, DNS server can let you know my IP address. Because this is a fully qualified domain name, you can request this. You can request my IP address from any DNS server. So such things are called as FQDN. So contact field is always going to contain either the fully qualified domain name for that user, or it should be containing an IP address. In this case, it is containing fully qualified domain name, which is acceptable. And content length is 0. That means we are not attaching any multimedia parameters here, which belongs to some other protocol. So content length is 0, not present here in this the content length part. So how so according to our protocol logic, how many are actually present in your if you go back, um, start line is there, which is the request line, and message header containing many header fields, followed by the CRLF is going to be present, obviously, which is not shown there that it is present as CRLF. But message body is optional. When it is going to be optional, when the content length is 0, then the message body won't be present, because higher layer multimedia parameters are not present in your SIP message. So that is how the SIP register method has been originated. And if you look at the next message, F2 401 unauthorized a message. So here the status line is going to be reverse. So what is the meaning of reverse? In case of request line, you have method name first, request URI next, SIP version last. But if you take your answer part, status line, what is happening with SIP version will be first, space, status code, what happened to your SIP message that you sent, and reason, explanation of the reason, what happened. So there is, you are going to get a reason back. Then you are going to have this CRLF. So if you see that here, SIP 2.0 is the version name, space, 401 is your code, status code, space, and this is a reason phrase, stands for unauthorized. Um, and CRLF, carriage return line field, next line. In the next line, we have the via field. Now this via field is the same via field as the earlier one, but we have something called as a branch parameter. and there is some received IP address information attached. So we did not learn nothing about it other than just understanding the wire field is adding the information about the component who is sending it, like either forwarding it or sending it. That guy's address details will be added in the wire field. So that exactly is what we have understood about wire. We will learn more about the wire later. But there is the from field and to field, which are obviously the same, not changed when the reply is coming back. Call ID is not changed. Earlier one, whatever the call ID we have seen earlier, it is going to be the same. And C sequence is register. So this status is replied for your register method. Your status is coming back for your register method, and the server which is replying with unauthorized, it is telling you that, hey man, I'm sending you one nonce, and I'm going to ask you to generate a response by using the MD5 hash algorithm. You please authenticate yourself. I know that you are a genuine guy, but I want you to prove that you are the actual user. You, nobody is like trying to imitate you or trying to register with your name and try to deceive us. So it is the time for you to authenticate. So it is sending a header field called as authenticate and sending the details inside that authenticate. You have to do authentication mechanism by taking these nonce. It is just like random number in case of our LTE operations, sending the random number and algorithm details. And the component who originated the registrations, that guy's job is to send reply for this. Content length is zero. There is no multimedia information because this operation is not related to multimedia steps. So in step F3, the Bob guy is sending a message to SIP server register method SIPs ss2.biloxy.example.com, the same server we are sending the request to with the SIP version via uh, all these things are absolutely same from to call ID, but C sequence 2, we are sending the same register method second time. Contact field is the same, which is your FQD and fully qualified domain name. And but here we have what? Here we have what? There is this authentication information telling him that this is the nonce you have sent me, and I am generating this response. I have generated this response with my MD5 hash algorithm. So please verify whether my response is correct or not. So when you add this response information with content length 0, there is no multimedia parameters attached. Ultimately, you are sending this response. This response will be validated by the server to validate whether the SIP user who is initiating this register method is a genuine guy or not a genuine guy. To validate that, we'll be using this response information. Once he found out that this response is accurate, it is going to reply back with a 200 OK. SIP server is sending to Bob. SIP 2.0 is the version name, 200 space reason phrase is OK, and the wire field from field to field are same call ID. This response is received for the SIP message you have originated second time, second register method, not for the first register method, because only in the second register method you have sent the authentic authorization details or your authentication details. By validating those authentication details, your SIP response is a positive response from the registration server, and he has noted down that your IP address is this. Bob at the rate of client.biloxy.example.com is your IP address. This is basically a FQD and fully qualified domain name which can be converted into IP address by contacting any DNS server. Either you can directly quote your IP address or you can quote your FQD. And in this case, it is quoting FQD and it is not quoting IP address. Content length is again 0, the content length part. If I show you the same thing in Wireshark log, it looks like this. So you have the in Wireshark I have put a filter here on SIP, so only I'll be able to see the SIP messages. So if I show you one example related to the registration, it is here. So SIP register method. When I open this SIP register, you can see the information displayed beautifully here in Wireshark. So we have request line and the message header. We don't have the message content, message body. So if you open the request line, if you see the request line, it is containing the name of the method, space. Literally everything is data here, even the space also. So this portion is basically this byte is SIP. This byte is the space. Okay, so this is the R. This is the space. So everything is a character, everything is an English character, register space, SIP verso.com. You are registering with a server called as verso.com, SIP 2.0. And in the message header, you are going to have many header fields. Each header field is this first one is via, which we have ignored for time being. There is a from field, there is a to field, both are actually same in register method. Contact is even at the rate of 257.7.205. Here, this guy who is doing the initiating the register method is quoting the username, but he is not quoting the FQD, and instead of it, it is quoting the IP address and port number. So it is telling the server that, hey, if somebody wanted to make a call to me, I know that you will get the incoming requests. So when any such incoming request arrives, you need to forward the call to me on this IP address and on this port number. My SIP operations are going on this IP address on this port number. So contact detail is basically like you providing your contact details at the time of performing the registration operation. But for every SIP procedure that you initiate, there must be unique call ID. So simply a random number, which is unique random number. Make sure that it is unique across the world. And C sequence can be any number. It can be one register, or it can be two register, or it can be any number register. So it can be a random number also. Expires 1800. So one field is added, expires here, additional field, maximum forward 70. User agent is what kind of a device this guy is using. He is using Verso soft phone release 1104W. So that is the user agent type. User agent can be a SIP phone also, like Cisco SIP phone. It can explain. So what kind of a device you are using for your SIP operations? You are sending the device related details. Content length is 0. Because content length is 0, there is no message body present. Multimedia parameters are not there. But at the last field after the content length, if you look at every field, so this field is up to here, we have CRLF. So you can see this is CR, this is LF. Carriage return value is 13. 8 plus 4 plus 1, this is 13. And line feed value is 10. 1010, 8 plus 2, 10. So you have one CRLF here. So after every field, we'll have a CRLF. So even after the request line, you will have a CRLF. At the end of the request line, you see that the last two things, after this whole thing is completed, you are going to have a CRLF. This is 13, this is 10 CRLF. Then your header fields are starting, via header field, etc. are starting. After every header field also, so this is the via header field, each character is a byte, but at the end of this header field, what we are going to end up having is CRLF. You can see 1101 is 13, 1010 is 10. That is the CRLF. So after every field, last two bytes are going to be CR and LF. Carriage return line feed represents that is the end of that field. Next field is starting. So after every field. But once you come to the last field, we have the carriage return, which is 13, line feed, which is 10. After that is completed, you have another carriage return, line feed. That is what I've told you earlier. That represents the end of the header. So each header field will contain one carriage return line field, carriage return line feed, And once the headers are completed, you will have two carriage return line feeds. So that is how the SIP processing, SIP message processing will happen in SIP protocol. So if you send register, the guy who is responding back, it is sending a status line SIP 2.0 and 200 OK. It is directly sent to 200 OK. Is not asking you for any authentication and all that. Simply it is replying back and saying, I'm accepting your registration. Your binding is completed. And it is sending back from and to address call ID, C sequence, the sequence number of your initialized method, contact. I have noted down your IP address. I am quoting the expiry time, my own expiry time, maximum forward 70, and user agent is the same details. Yellow, like the server is replying back and reporting the client that these are the methods I will allow. If you want, you can initiate these methods. You can initiate invite method, cancel method, buy method, info method, refer method. You cannot use any other methods, only these methods you could use. Content length is 0, not containing any kind of um, message body or message information. It is not containing any such details. All right. Um, so that is the register part. For example, let us take the call part. Um, if there is a SIP guy who is initiating a call from IP address 195 to 204, so there is a request line. It is an invite method. Invite method is for a SIP call invite. You are initiating a SIP session. It could be a voice session. It could be any multimedia session. Doesn't matter what it is. We don't care also what exactly is this type of the SIP session. But it is a SIP session initiation. So whoever is initiating it to a guy called as Francisco at bestel.com on a port number 55060. So this is the domain host name, and this is the port number where the host is operating with his services. This is the username. Francisco is the username. SIP colon is the mandatory part. SIP 2.0 is anyway version. After that we have CRLF. You have the message header. Uh, in the message header, you see two via fields. Now it is the time for me to explain the via fields. What exactly is this via fields, and what do we add for? This wire fields is a concept that we have already studied in a different way in some other protocol. You have to tell me where we have studied after I explain this wire field concept. So keep listening to this carefully and give a guess about where did we use this mechanism, in what format we have used it. For example, this is a SIP client, and there is a middle components like your SIP proxies. So there are three SIP proxies. This is the SIP server, let us suppose. So this guy has sent a SIP request to this fellow. At the time of sending here, uh, this guy's information will be added in the via field. This guy's information will be added in the via field. So at the time when the message is coming, only one via field will be present. But when the same message is getting forwarded to the next SIP proxy, the previous via field will be there, which is added by this fellow, first guy. Along with that, this guy is going to include his own details, his own address details, this fellow I'm talking about, in the form of via field. Once this goes here to this component, when he is forwarding it to the next guy, the previous two via fields will be as it is present, and this fellow is going to add his own information in the form of a via field. Now it will become three vias. And when this guy receives it, and he is going to forward it to the actual server, now the previous three vias will be as it is in the message. Um, all the three via fields will be present. Additionally, this fellow is going to add his own via field. So by the time this guy is receiving your SIP protocol message, totally inside that SIP protocol message, you will have four via fields that are present. Now, why these via fields are, and what is the purpose of these via fields? When a SIP message is traveling from the source to destination, or from address to address, when it is going through the SIP proxies, the criteria that is followed by the SIP proxies is the to address field. So they will be looking into the to address field, and they will start forwarding that SIP message towards that to address field. So they will identify which next SIP proxy can help you out, and they will forward it to that next SIP proxy. It will be forwarded from that SIP proxy to another SIP proxy. From there, it will forward to another SIP proxy. Finally, it will reach the server. So how the SIP request messages are traveling? SIP request message travels always with the help of the information that is added in the form of your to header field, to to header field. But whereas the response message that we are going to get back, the status message that we are going to get back from the server will not travel with the help of the to field. It will not. Instead, it will not be even your SIP proxies will not be looking into the to field when the reply is coming back. Instead, the reply will come back with the help of the via fields. How come? Because right now there are four via fields that are received by the server. What does the server do is, hey, the topmost via field is the address of the SIP proxy who have sent me the request. I know that I need to send the reply, the SIP status message back to this guy on this address, on this IP address details that are provided in the topmost via field. So by including all the four via fields in the reply or in the answer or the status, it will be reporting this message status report to this guy. What does this guy do? Once he receives the response message or the status message or response message, once we receive it, this guy is going to remove the topmost via header field, and he is going to say that I'm going to forward the same response back to this fellow with only containing three via fields inside, because the topmost via field is mine. Anyway, I have already received it. I should not be forwarding it to the other guy. I should simply be ignoring that and forwarding only the remaining three vias. To which user I have to forward it to? To the topmost one is mine. I am removing it. The next one is where I have to forward the SIP response. I forward it to this fellow. When this guy gets it, he says that the topmost wire field is again mine. So this guy is going to remove this wire field and forward the response message to this wire, the information attached in this wire field. The response will come here. And this guy says that the topmost wire field is mine. I'll remove it. I have to send the reply back to this particular information attached in this wire field that will come to this guy. This guy says that, okay, I have received the response. So ultimately the logic is, it will be at the time of sending the protocol messages, each component who is forwarding it is adding their own information, address related information, either the IP address and port number directly, or they are going to include FQDN and port number, fully qualified domain name and port number information. They are going to attach those details in the with a name called as a via field. Every component is going to attach those details, and when the reply is going to get generated, the reply message always travel with the help of via fields. But by the time the generator of the message receives the response message, how many via fields will be present inside is exactly only one via field present. That is his own via field present, because every component who is adding the via fields at the time of sending a request message, when they are going to receive the response message and revert back with the response to the previous component, they are going to remove their own via information from it. So vias will be added, vias will be removed. Okay. So can anybody tell me now, this is representing what logic that we have studied earlier? We already studied one thing similar to that.
So SI class, we have already studied this concept.
Which one?
So this is
OSI
something
class.
related to DRA, and we are using as a formatting purpose.
Yes. So we have used
Studied in IP packet flow.
so we have used a similar procedure in diameter protocol, we have something called as hop by hop ID. You remember? So diameter messages will be forwarded, diameter request messages will be forwarded from client to server with the help of the routing AVPs attached, like destination rem and destination host AVPs. The request message will travel. But at the time of sending the request message, we will be creating a sequence of hop by hop IDs, and that will be noted down by the middle components um, called as diameter proxies. But here noting down is not needed. The components we are sending will attach their own information in with the help of the wire field, and they know that once the request is sent, once they receive the reply back, they need to remove the topmost wire field from that and push the information to the previous component. That is how these components will behave. So this wire field attaching in your SIP messages is almost equivalent to the hop by hop ID concept that we are using in diameter. That means both these protocols are actually, if you remember, diameter protocol is a application level routing protocol, and your SIP also is application level routing protocol. So all the application level routing protocols will work in a similar fashion. So that is exactly what is happening over here. So you understood the purpose of the wire field? Is that clear? Okay. Now, after the wire field, okay, I will explain the details that are present in the wire field. SIP 2.0 UDP. So it is using SIP 2.0 version, and it is using UDP transport. The IP address is this, on which that particular component who is attaching this wire field is operating. And there is a branch parameter. So what is this branch parameter represents? The branch parameter is for maintaining the transactions at the components, like SIP transactions. So for every SIP transaction that we have received and forwarded, you are going to include a new branch parameter. For example, if you take one SIP proxy, he has received 500 requests, forwarded 500 requests to the next component. There will be 500 different branch parameters it will attach. These are just random numbers which are not going to be same for two calls. The branch parameters will be different. With the help of the branch parameter, you will be able to understand you will be able to do the comparison between the request messages you have forwarded and the response messages you have received back with the help of the branch parameter, because branch parameter will be different for different mobile phones. All right. So why we see two wire fields? That means when we are seeing two wire fields means already this message we are capturing on the server side, not on the client side. If we are captured the message on the client side, only one wire field will be present. If we have captured it on the server side, it may be containing two wire fields. First wire field may be this wire field may be clients, and this wire field may be the your SIP proxy components wire field. So two wire fields are there. So by the time the server received it, there are two wire fields. So server will reply back to this component. This component will forward it to this component. It is like that. Okay. So now we understood the concept there about via. And in the from, we have like who is initiating this invite method. And there is something called as a tag. What the hell is this tag field that is associated with the from field? In you if you remember our LTE operations, we call our RRC as RRC idle state and RRC connected state. We have two mechanisms: RRC idle, RRC connected. What these two things are? there is definitely difference between those two things. Similarly, in case of SIP, we have a concept called as outside the dialogue and within the dialogue. Outside the dialogue, whatever is the dialogue, we don't know what is the dialogue right now, but we have outside the dialogue and within the dialogue. What is this dialogue? We don't know what is this meaning of dialogue, but I'm going to explain that meaning of dialogue. Dialogue is a set of three parameters in SIP. Two tags plus one thing called as call ID. If these three parameters are available for any SIP session, two tags and one call ID, then we can say that the dialogue is established between the client and server with these three parameters present. But if not all the three parameters present, two tags and call ID, then we say that it is outside the dialogue. If all the three are present, then we say that it is inside the dialogue. So the logic is pretty simple. Outside the dialogue, inside the dialogue. So right now, how many tags are present? The tag field is right now present for from field, and there is no tag present in the to field. The tag is going to be created in the to field by the receiving guy, the guy who is going to respond to your SIP invite method. That guy is going to create the tag field. It is just like if eNodeB is sending a S1AP protocol message to MME, eNodeB will create one S1AP UEID, and in the reply message, MME will be creating one S1AP UEID that is going to be used by MME for recognizing the mobile. So this is eNodeB's ID, and this is MME's ID, almost a similar kind of activity. The guy who is originating the protocol message have generated one tag, and the guy who is going to receive that protocol, SIP protocol message, the destination guy, is going to include the tag field in the reply message. But right now the tag is not there. But there is a call ID originated by the sender. So basically, out of the three fields that are required, two fields are already present. So one tag is there, one call ID is there. So if the receiver who is going to accept this SIP request method, if he is going to generate a reply or at least a provisional reply, in the reply or a provisional reply, if the receiver can send another tag field, the moment once the tag field arrives at the client, the guy who originated the SIP message, now both client and server, we can say, entered into a state called as inside the dialogue, because there is these three parameters created, and these three parameters are going to be used continuously till the end of the SIP session. We will be using these three parameters to recognize what is going on within this particular related to within this particular dialogue. So there can be multiple dialogues created between one client and server. If we are initiating multiple services between one client and server, it is possible you can have multiple dialogues also in SIP. You don't need to have a single dialogue, you can have multiple dialogues as well. But one SIP session we will be having one dialogue. So there is dialogue means these three parameters available: from tag, to tag, and call ID. If all the three are there, then we call it as the components are within the dialogue. Right now, the components are not within the dialogue. We say that it is outside the dialogue. Okay, so that is this tag field that we have here. And to tag we have here not there. Call ID is present. C sequence we know. Contact is what IP address it is operating, what port number the SIP call originating is operating on, what port number. There is content type and content length present. Content type is SDP. Session description protocol is additional information has been attached here. Content length is 229 bytes, and content type is SDP information. Actually, SIP message is going to be finished with message header itself. SIP message will contain request line, message header, and this message body won't be considered as a SIP message. It belongs to a third-party multimedia application. What is the third-party multimedia application? SDP stands for Session Description Protocol. So it is containing some information related to the session description. What details are present in this message body? It is containing a lot of parameters, and the major important parameters it is sending are going to be this. It is telling that, hey, my IP address is going to be this. Um, my IP address is going to be this, and my port number is going, audio port number is going to be this for receiving incoming voice traffic. So um, in the message header, what details are sent in the message header? You are sending your IP address and port number. What this IP address and this port number? This is for signaling messages. Whatever that is present in the message header is for SIP signaling message reception. It is telling that this is my IP address and my port number for receiving the SIP messages from the server. Client is telling the server, this is my IP address and port number on which I wanted to receive the SIP messages. But this is the IP address and port number on which I wanted to receive the user traffic. So if you want to send any voice packets, you have to send it on this IP address and on this port number 40,376. What are the different codecs I have, voice codecs I have? I have pulse code modulation, two types of codecs I have, PCMA and PCMU. And there is a G729 codec available, G723 codec available. These are different voice codecs that are available. It is suggesting that you can pick up any one of these four voice codecs. 8000 here represents data rate. It is 8 kbps data rate you are operating on. The last media attribute send receive represent the traffic is bidirectional traffic. It is not a unidirectional thing. I can send the traffic or I can receive the traffic. So that is what is the client proposing. So these are your user plane parameters. If this message body session description protocol is related to the user plane on which IP address and port number you will be receiving the user plane traffic. For example, you are connecting to Google server. If you connect to Google server, if your computer connecting to Google server, first your computer must know what is the Google server's IP address and on which port number the Google server is operating. Without knowing these two details, IP address and port number, you will never be able to establish any kind of a connection with any server and send any data or receive any application information. Not possible. You require IP address and port number. Similarly, if the client is proposing for a invite call, then the must send his IP address and port number on which he is supposed to receive the user data, and another IP address and port number on which it is receiving the SIP related protocol messages. This is his IP address and this is the port number on which you are operating for user data. Sorry, signaling messages, not user data. So a request method is proposed. When the request method is proposed from 195 to 204, 204 guy is replying back to 195, and it is SIP 2.0 100 trying. According to the story we have discussed, this 100 represent a provisional response in the status line. SIP version is 2.0, status code is 100. 100 is provisional, representing that, hey, I have received your request. I'm continue to process your request. It is not yet completed. It like your this is in the temporary state or middle state. It is not yet processed. I'm not sending a final reply to you. This is not a final reply. That is the meaning of this. So that is the status line containing three details. Trying means I am doing my job, man. Please wait. It is not yet done, so you have to wait. And in the message header, you will find the same two via parameters that are received by the server. Server is including both via fields, sending it back to the proxy, and proxy will forward it to this client. And from address and to address are not changed. Same thing, same from address and same to address. Only difference is there is a to address change in the to address field. There is a tag has been attached here in the to address field. The moment the tag has been attached and this tag field is being going to be received by the client, we can say that once this tag is received by the client, both client and server are right now having three parameters: one tag in the from field, one tag of the to field, and combining it with the contact information. These three things together, we call it as a dialogue established between the client and server. So client may have initiated 20 dialogues with 20 servers. So for each dialog, it will be using a different tag field and a different contact, different call ID field, a unique ID. So with these three fields, two tags and call ID, we will call it as dialog. So this is the unique call ID number and one tag field, another tag field. It is going to uniquely identify your session or the dialog. We call it as. Um, so contact is the Francisco guy is replying back, hey, my IP address on which I'm going to receive the SIP signaling messages is 257.7.204. My port number is 5061. He's quoting his SIP IP address and port number. It is not quoting the FQDN, fully qualified domain name. Instead of it, it is quoting the IP address and the port number. And call ID is as it is. And this status is being reported for the invite method. And the server is explaining you that I'm using Xlite release 11.1103 software. I'm using this software on my machine, Xlite release 1103, and the content length is 0. There is no SDP information attached. Reason is this is not a final response. It is a provisional response from the server explaining the client that, hey, I have received it. Thank you. And I'm sending you a provisional response called as trying, but this is not final. You guys have to wait for it. And then another provisional response is being sent by the server immediately, 204 to 195. One more provisional response is going, SIP 2.0, 180 ringing. That means that phone is ringing basically. Your SIP session is being shown on to the server user agent server, the receiving guy. It is being shown to him, and that is the meaning of this ringing. So we have two via fields. There is a from address and there is a to address. So same tags are reused. Contact field, same IP address and port number, call ID, and this again this provisional response 180 is also for the same invite method, and he is quoting his server details and content length. Even this also is a provisional response. It is not a final response. The final response is here. This 200 OK is for this register method, guys. This register is having this 200 OK. This invite method is having this 200 OK. How do I know? Because in this 200 OK, I can see that this is for a register method. This 200 OK is for a invite method. So actually the traffic is mixed traffic here. So this is the 200 OK. In this 200 OK, what details we have? Status line, 200 represents final response, okay. And in the message header, we have two via fields, from field, to field, contact, all these things are same every time. But this time we have the SDP information present. This time it is going to have FDP information present. Um, Session description protocol data. Server details are there here, and content length is 298 bytes. So what information is coming from the server in the SDP? It is quoting its IP address for the receiving the voice traffic. Hey, this is the IP address and audio port number for me is 8000. And the codecs that I have is pulse code modulation, U and A both I have. I have a GSM codec available as well. I have ILBC codec, I have Speaks codec, I have telephone event codec, I have one more codec, FMTP codec I have. So I have all these codecs I'm having. So obviously, out of these many codecs that I have and you have, whichever are the common codecs, we'll use one of the common codecs. So they'll pick up the common codecs. The only two common codecs that are available are pulse code modulation codecs. These two codecs are available in both invite method. We have PCMA and PCMU. And this guy who is sending the response, here also we are having PCMU and PCMA. Both these codecs are common between the two things. All right. So, what are we going to have after this SIP session information? SIP session description protocol information. What details we are going to have here? Once these details are sent, what does um, what does the server do? What does the client do after receiving this 200 OK? It is going to send an acknowledgement back. Um, Acknowledgements are typically sent for the final responses because the server reported with this final response 200 OK, and the client is supposed to send a acknowledgement for that. So it is reporting that I am sending a acknowledgement to Francisco guy. SIP version is 2.0. I'm going to tell him that, hey, I'm sending you the acknowledgement for this particular call ID with this to tag and from tag that we have used. So you can easily understand that I'm sending this acknowledgement message as part of your 200 OK message. How do we know that? How can you relate it to 200 OK? Because in 200 OK, whatever the dialog parameters you have, the tag field in the from field and tag field in the to field and the contact call ID here 12013223, the same things are going to be present in the acknowledgement message as well. So you have the same from tag, same to tag, and the same call ID 12013223. So if you have the same dialog parameters, we can know that this acknowledgement is part of the dialogue that is already ongoing, invite and OK. So as long as these same dialogue parameters are present, you can understand that those messages are related to this particular SIP transaction that is ongoing between the client and server. You can understand it. And you have the C sequence. Yeah.
Uh, Sir, what is that colon 55061 in that second via header field?
Which one?
55061 in that second via header field. Sir, second via header field?
Yeah, here.
Yes, sir.
This is
Yeah,
the port
in
number.
that 55061.
This is the port
So
number.
then when it is moving from another proxy, then another port number
No,
should be there,
basically
no?
client and proxy are present on the same machine, but client is operating on a port number 55061 and proxy is operating on a different port number. Proxy is not sending the port number to the server because from this port number, if you look at the request message, in the request message already this guy has used source port as 50610. So because this message is coming from the proxy, we know that on the proxy side the port number is 5060. That information is not included in the wire field, but client port number is 55061. So basically here the scenario is the client and proxy are both present physically in the same machine. Their IP address is the same, but their client software, like for example, if the client software that is running is like Xlite or whatever, that is running on port number 55061 on the same machine, and the proxies, your proxy application or the proxy software is running on a port number called as 5060. Are you understanding it? It is coming like this, and then from here it is coming to your server. Why this is the case? Because this log file is captured on a simulated machine, on a simulated environment. Its log file is not captured on the real environment. If it is a real environment, client will have a different IP address and port number, proxy will have a different IP address and port number, server will have a different IP address and port number, because all the three components will be three different hardwares and they will be having three different IP addresses, and their using port numbers will might be different as well. But at least IP addresses will be different. But whenever we see that IP addresses are same here, we have to imagine that the client and proxy are running on the same machine.
Yeah, got it, sir. And sir, 5060 is that SIP default port, I think.
Okay, I'll tell this to you. Assume that proxy is operating on port number 5060. Now, when client is sending it to proxy, client uses a port number 55061. He will use this port number 55061. From that, he will be sending the traffic to the same computer. IP address is the same from same computer to same computer, from one port number 55061 to port number 5060. It will be sending it to this port number as the destination. Once the proxy software receives it, proxy need to forward it to your server. Server is running on a different IP address, which is 204. The IP address is, it is a different computer or a different IP address. So this 195 is where these two guys are present. Client is present on this 195, as well as your proxy is also present on 195. Only difference is your client software is associated with port number 55061. Proxy software is associated with port number 5060. Internally, the protocol message has been, when it is moving from client to proxy, client included his wire details. That is the first wire that is present here. These are the client details. Client is noting down that my IP address is 200.57.7.195. My port number is 55061. Whoever is going to send the reply back to me, they must send me the reply back on this particular port number 55061. And when he forwards this to this fellow proxy found out that it need to be forwarded to server. At the time of forwarding it to server, he is including his details. What are the details it is adding? It is adding only IP address. It is not quoting the port number. When it is not quoting the port number, server understands that I need to send the reply message back to the proxy on the on the port number that is present in the UDP protocol. 5060 is the port number of the proxy. So that from that only we are recognizing that the proxy's port number is 5060. So the server will be sending back the reply to 5060, and the proxy will be sending this reply back to 55061 that is running on the same machine.
I got it, sir.
In a real environment, it won't look like this. Okay, great. SIP description protocol. Okay, so where we are, acknowledgement. So once the acknowledgement is sent to this call report, so the call acceptance. So with that, we can say that the SIP call is established. The SIP call is always going to be three steps. Invite, 200 OK, and acknowledgement. It is always going to be three messages always. It is going to be. Okay. And after this, typically what happens after the call is established? Um, I'm going to remove the SIP. I'm going to keep the traffic for RTP and RTCP. I'm going to keep this traffic here, RTP or RTCP traffic. Okay. So from these two guys who are exchanging the traffic, the user traffic will travel with the help of protocol called as RTP. So 204 is one guy, 196 is the other guy. User traffic is going, and the traffic that is traveling is pulse code modulation A traffic, G.711 PCMA traffic is going on. So on the port numbers that they have exchanged. If you see even the SIP messages as well along with this, if you go to this OK message that we have here, in the OK message you see, in the invite message, if you go to the media body, the audio port number initiated by the client is 40376, and the IP address initiated by the client is 257.7.186. And in the OK message that is sent by the server has told that my IP address is 257.7.204, and my audio port number is 8000. So the audio port number is that. If you see the traffic by removing this SIP part right now, and we can see that the traffic is exactly going on those IP addresses and port numbers. The 204 guy who is the server maybe saying a hi or something. So if you see this UDP, the port number it is using is 8000. The destination port number is 40376. That is initiated by the client. We are sending the RTP traffic on that. So this RTP is real-time transport protocol, which will add timing related information. What information will be present in the header, we will see. But that is the UDP level port numbers will be added. At IP level, IP addresses will be added. So the source IP address is 257.7.204. Destination is 257.7.196. So this is the server guide. This is the client guide, and the RTP traffic is going on. Inside RTP, what will be there? Your voice traffic will be there present inside the RTP. Your voice payload will be present. It is the voice data. So, what is this RTP? The primary understanding of this RTP protocol is it will contain real-time application, real-time timer-related information, typically, for the purpose of making the receiving guy understand about this situation. RTP version we are using is 10 version 2, and the padding bit is 0, extension bit is 0. That means no more extension headers will be there, and the number of contributing source identifiers count is 0. Typically, the number of contributing source identifiers count will be increasing to 1, 2, 3, 4, etc. if the voice payload is containing the data gathered from multiple sources. For example, if we are having a conference call, if three people are speaking at the same time, shouting at each other, and if 30 people are listening, now what happens is whatever the data that is going to be sent by these three people will come to the server, and the server will merge that data and send that data to remaining 30 people who are patiently listening to these three guys fighting with each other. But the voice data is going to be a mixed voice. It is a mixture of three guys speaking. It is in that sense, contributing source identifiers count may be equal to 2. Actually, 2 represents indirectly 3. 0 represents 1. 1 represents 2. 2 represents 3. 3 users are speaking at this time. So that contributing source identifiers count is a way of explaining how many individual users data is present inside. But when the value is 0, it is a single user, and there are no multiple contributing source guys present there. It is the meaning is that. And here one marker is set to true is always going to be either at the starting or at the ending. So if it is a first packet, we will be setting the marker to true, representing that this is the first voice packet we are sending. So always in the first voice packet, marker will be set to true. And the payload type is what kind of a voice payload we are sending. ITUT G.711 PCMA voice codec, we are sending payload voice traffic is sent with that codec value. Why we have to report this payload type? Because the other guy need to decode it and play it in the human voice format. So to decode it, you require to send the payload type information. For example, MP3 is different, AVI is different, and MP4 is different, and various other formats are different. If you wanted to play MP3 file, you need to use a MP3 player, MP3 audio file or whatever. If you are using a software which cannot play MP3 file, that means that that software doesn't support MP3 codec. So when you try to play it, it won't be able to understand MP3 data. It cannot convert it back into the voice information, and it cannot play it for you. So the codecs are required to decode your payload. So you have to specify what kind of a payload you are sending. 0.711 PCMA. With the help of this information, the receiving system is going to decode that information. Sequence number is going to be incremental number 1, 2, 3, 4 for each audio packet that you are going to send. After you send like 160 packets, the number will be 160. So sequence number is just a normal concept. Timestamp is a way of explaining after how many seconds after data after call is established, after how many milliseconds, not even seconds after, or how many milliseconds your voice has got generated after 160 milliseconds, the timestamp value. So the meaning is your voice frame will be generated every 160 milliseconds once. So in a second, roughly 6 voice frames will be generated. So that is that. And synchronization source identifier is going to identify who is the source in the who is the source guy who is sending the data. So when there is only one guy, every time you will be using the same ID representing that it is that single guy. Okay, so synchronization source identifier. If there are multiple guys, one ID will represent a combination of one set of users. For example, in case of GoToMeeting, there could be a lot of source identifiers. Reason is when I'm speaking, some others may be asking questions. The remaining people might be getting the mixed voice. Do you need to understand who and all are speaking right now? So it will be displayed also who is talking right now, the name of the person who is talking. That information will be displayed there. So how the receiving computers can detect who is speaking is with the help of that ID, this synchronization source identifier, whose voice data it is. And this actual payload. If you look at the payload, the amount of payload we are sending right now is 160 bytes. So you can easily imagine in 160 milliseconds we are generating 160 bytes. In 1000 milliseconds we will generate 1000 bytes. Normal fifth class standard mathematics. 160 milliseconds. Every 160 milliseconds we are generating 160 bytes of payload. So 1000 milliseconds it is going to be 1000 bytes. So if you take 1000 bytes, each byte is 8 bits. 1000 into 8 is going to be 8000 bits. That is 8 kbps data rate that we are operating with. So your voice data rate is 8000 kbps. That is what they have proposed also at the starting, the data rate of the voice payload. So this is the actual payload which need to be converted into voice. It is not showing the voice data in the English format or whatever, because this is voice data. Simply your RTP protocol will show this. So your voice data is packed into RTP protocol header. RTP protocol header importantly noting down information like what kind of payload traffic it is and what is the sequence number and timestamp, and similar kind of details it is attaching, and it is attaching corresponding UDP port numbers perfectly that are exchanged and IP addresses perfectly and sending it out. That is your RTP. If you look at the next RTP packet, you will see incremental numbers. Payload type is the same. Marker is set to false because it is not the starting packet. Only starting packet and ending packet will have the marker set to true because this is not the starting or not the ending. It is the second packet. Marker is set to false. Sequence number is 2 and the timestamp is 320, meaning is this voice payload is generated at the end of the 320th millisecond time unit. It is generated yet. So it is representing that the timestamp 320 is representing it. So again the payload 160 bytes of payload after the end of 320 milliseconds time unit. So the concept of RTP is pretty simple. It will be noting down the information here. Now you can easily understand the logic. For example, if the sequence number 2 is received and after that the sequence number 3 is received, which says that it is timestamp value is 480. But instead of arriving at 480 milliseconds on the receiving side, if it arrives at 520 milliseconds or whatever, the receiving guy will think that this is too much delayed. I'm going to drop this voice frame because voice frame is delayed too much in the network. It did not receive to us in correct amount of time. So there is no need for us to actually play this delayed voice frame. So you will be able to detect that with the help of these timestamp values by finding out how much variance is between two continuous voice frames. If any voice frame is delayed by more than some amount of X amount of time that you can give as a leverage, you're going to drop that voice frame and you will pay the next voice frame. Of course, the receiving guy who is going to receive this data and play it in the form of voice, he will be actually having some kind of problem in understanding these things. Definitely, some one voice frames will not be continuous. If one voice frame is missing because it is delayed, the receiving is decided to ignore it. You will play this voice, and you'll be playing the next voice, and you will not be having anything here in the middle if there is no frame played in that particular time. So you will see the gap in the sentence. You will see that the voice is cracking whenever the voice frames are missing or delayed. Okay, so for that purpose only, this real-time protocol would be used. RTP traffic would be used. And what is the purpose of this RTCP protocol? RTCP protocol will be sending statistics about RTP. Its duty is to send statistics on RTP. What is the meaning of statistics on RTP? The 204 guy had so far sent two RTP packets to 196. This is the first one, this is the second one. 204 immediately sending a RTCP statistic report to 196. What is the report it is sending? It is sending a report called as a sender report, telling him that, hey, the packet type is the sender report. It is length is 52 bytes of information, and I am generating this report for a time frame between this time to this time. From this time to this time, I am report generating the report for. This time is the real time. What do you mean by the real time? This is in terms of real world time. For example, so you can see that the real world time is this January 14th, 2005, based on the values that are present here. How it is estimating that this particular time is this? This is number of seconds that are passed from year 2000 January 1st, midnight 12 o'clock. They start from that time. Every second you will have an incremental value. So it is going to be that way. The time will be represented in absolute seconds in here. It is called as the NTP timestamp. All your computers which are synchronized with the NTP servers will also be getting a value. When they decode that value, they will understand what is the ongoing time. So always the time is relative time, starting from 2000 year 2000 um, uh, night 12 o'clock, 12 a.m. So that's going to be our starting time. That will be represented as 0. Next second will be 1, next second will be 2, next second will be 3. It's like that. So it is sending that report, and in the report it is including that the last RTP timestamp I'm reporting up to is up to 320. Number of packets I have sent so far is 2 packets to you, and the number of bytes of data I have sent so far to you is 320 bytes. So this is like the statistics about what you have done on RTP. RTCP, real-time control protocol, is about statistics. So you will have two types of reports, sender reports and receiver reports. Sender reports will be telling the receiver that till now how many packets I have sent and how many bytes of data I have sent, till what RTP timestamp I have sent the packets to you, till what RTP timestamp I have sent it. So you will be reporting this kind of sending this kind of a report, a sender report. What is this receiver report is about? If the receiver receives something, he is going to give a report back to you telling you that, hey, out of the 2 packets you have sent, I have received all the 2 packets. Nothing is missing, and no delay happened to your packets that you have sent. I have received within time. So it will be reporting that kind of a report. Or if you have sent 100 packets one by one, after 100 packets you have sent a sender report asking the receiver to report back with a receiver report. This guy is going to send a receiver report in that explain that, hey, out of the 100 packets you have sent, I've only received 98 packets, 2 packets are missing, 57th one or 92nd one, something like that. 2 packets are missing, and there are some packets which are little delayed also. There is some amount of time delay or the jitter. I'm reporting it to you. Like that, it will be sending the receiver report. With the help of the receiver report, the sender will be able to guess what is the quality of service achieved for your call, what is the kind of quality of service that we have attained. Is it really 5 stars quality that we have got, or it is a 4 star quality, or is it a 2 star quality or a 1 star quality? So like that, it will be able to estimate the quality of service that you have achieved on that call, you have achieved on that particular session. So the sender reports or receiver reports are related to that. So the guy who is sending the receiver report, he will explain that I never might have received anything from you. So there is no delay, there is no timestamp, there is no jitter. Number of packets I have received from your side is 0. Why? So far, only 204 guy have sent the packets to 196. 204 is sending how many reports? It is sending sender report, receiver report. In the receiver report, he says that the number of packets I have received is 0. Why it is 0? Because he never received any packet. We have only he has sent it. So only in the sender report he is mentioning that I have sent 2 packets, man, so far to you. 320 bytes of data. Maximum RTP timestamp I have sent up to is 320. I am reporting this sender report. So you will have the receiver reports. Yes, you will have receiver reports, but receiver reports only will be meaningful if you have received something from the other guy and you are reporting to the other guy that how many you have received and how much jitter you have, etc. So what is the delay? How much amount of inter-arrival jitter between the packets, between one packet to another packet? Like that, you will be explaining about these kind of details. Okay, so but anyhow, when you don't have anything received, you have nothing to report. So you will be just reporting with all blank values, all zeros, etc. So that's the RTCP part. So this RTP and RTCP, RTP will be attaching real time values, sequence numbers and timestamps when the packet is getting generated. Receiving guy is going to use these values to align the receiving packets. If any packet is received out of order or arrived very late, the receiving guy is going to throw that packet into dustbin without playing it. So this information that is attached for the live packets, live payload, will help the receiver to identify which voice packets are, which voice packets are bad voice packets. Okay, for example, you can just consider this scenario. There is one router in the internet which received the one IP packet, but because right now it is facing a very heavy load, it is taking a lot of time to process this IP packet, which is containing one payload information inside. While this is not yet processed, next voice packet is already arrived after 160 milliseconds. But luckily, what happened, you don't know. This voice packet has been processed first, and it is sent out. After sending this out, we started sending this out. If receiver receives this 2 packets one by one, he received this packet first, and he received this packet next because it is arriving late. Now, if you already started playing this, you should never play this. How do you identify that this voice frame is not the next voice frame? This voice frame is the previous voice frame. You can easily identify with the help of the sequence numbers and timestamp that is attached. Maybe this might be containing a timestamp 720. This is containing a timestamp, for example, 880, let us suppose. Now you can recognize 880 arrived. After 880 arrived, 720 is arriving. You are already started playing this voice, but this voice frame, it is 720 is arriving late. You have to ignore this, you have to throw this into dustbin. So these sequence numbers and timestamps that you are attaching will help the receiving guy to order the voice frames and will be able to decide which voice frames to be played, which voice frames must be thrown into dustbin. So that is the RTP part. So RTP is free to throw the things into dustbin, and RTP will also estimate how many packets arrived late, how many packets never arrived. These kind of statistics it will be counting. After some time, once this guy sends a sender report explaining them that I have sent so far 100 packets, report me what happened. The other guy is going to send a report back saying that I have totally missed 4 packets so far. 4 are arrived very late with this much amount of intra-arrival jitter, and explain that complete statistics about that. It will be sending that report back to the sender. So that is the receiver report. It can happen in the reverse direction also. There will be voice packets coming from server to client as well. So if this guy sends the voice packets, it will be sending the sender report along with the voice packets. This guy is supposed to send the receiver report explaining how many packets he has received, how many are arrived late, how many are having inter-arrival jitter or delay between the packets. So like that, you have to send your receiver report. So you will be having sender reports and receiver reports in both the directions. In here between these two components, the sender and as well as the receiver. So I hope you are getting this RTP and RTCP part. So your RTP will contain all this information, but RTCP is not needed to be continuously sent. It will be sent once in a while, RTCP. So RTP keep on going, sequence number and timestamp. Sequence number timestamp keeps increasing. Sequence number timestamp. And there is no RTCP going here. Maybe RTCP might be there only once in a while. Maybe if you see somewhere in the middle, we have RTCP. So here we have one RTCP sender report explaining, so far I have sent you 749 packets. Number of octets of data I have sent you is this much. The last latest RTP timestamp is this much. So it is reporting this kind of a value after a long time. Actually, this is going on for other user. Actually, in this you will have it from 196 to 204, 749, and the number of octets and RTP timestamp. So like that, every now and then you will be having this RTP information getting exchanged. Um, you know, talking about these, how many packets sent from your side, how many packets sent from my side, etc., etc. Sender, receiver, sender report, receiver report. In the receiver report, you will have information about any delay occurred. If delay, okay, inter-arrival jitter, 9244 milliseconds of delay happened, so it is reporting. So the last sequence number it has received is this. Okay, the highest sequence number received, and it will be containing the number of lost packets, nothing. Cumulative number of lost packets, 0. Fraction lost packets are not there. Fully lost packets are not there. That means that everything is going good. You are not reporting anything bad about your ongoing operation. So you are reporting that everything related to your call is perfectly fine. Okay, so this is the kind of details you will be attaching in the form of receiver report. Okay, so with the help of these receiver reports, you will estimate the quality of service.